In this video, we will see the mesh analysis for the circuits which are involving the independent current sources. Generally, in our previous video, when we have seen about the mesh analysis, I have taken the circuit like this. Okay. Now what I am doing is, when you take the circuit with the independent voltage sources and the resistors, then that is a easy way of mesh analysis. Okay. Mesh analysis is easy for the circuits involve independent voltage sources and resistors. Okay, you can compare this one with our nodal analysis also. Okay, how? Nodal analysis is easy when the circuit is with only independent current sources and resistors. Okay, so these are the points you can able to remember. Then we went to supernodal analysis when independent voltage source is between two non-reference nodes. Okay, now similar to this supernodal analysis, in mesh analysis, we will be having super mesh analysis. Supernodal analysis we got when we have voltage source between the nodes, between the two non-reference nodes. Voltage source is required to be available between the two non-reference nodes, so then we can be able to go for super node. Super mesh means when independent current source is between two meshes. Okay, then we can able to go for super mesh analysis. That is what we are going to see now. Okay, so you see super node, super mesh, super node, super mesh. Voltage source is required to be available in between the two non-reference nodes. Your current source is required to be between the two meshes. Okay, in nodal analysis we will find node voltages. In the mesh analysis we will find mesh currents. So for this circuit, is it required to apply super mesh analysis? No. Why? It is mesh 1, it is mesh 2, it is mesh 3. We don't have any independent current source. So you no need to have to apply the super mesh analysis. Okay. So now we will take the circuit such that requires the super mesh analysis. Okay, that is what I am going to do. So I will take V1 with resistor R11 and it is R12, and previously we have taken here R12 resistor. Now I will take here some current source I0, then resistor, here one more resistor, here independent voltage source V3, and here resistor R13 is available. This is R23, this is R33. So the difference between previous circuit and this circuit is simply here we have R22 resistor previously. Now that has been replaced with the independent current source I0. Now you check for the condition. Do you have independent current source between the two meshes? Yes. Okay, here independent current source I naught is available between two meshes 1 and 2. Okay, we know what is a mesh 1, what is mesh 2, all these things already we know. It is mesh 1, it is mesh 2, it is mesh 3. Okay, then mesh current I1 is indicated, mesh current I2 is indicated, mesh current I3 is indicated. Now, so we will assume that you don't know about the super mesh. Super mesh is to be applied, all these things you don't know. Simply we'll go with the procedure of the mesh analysis only. Okay, so what will happen, you see, for example, KVL for mesh 1 I'm going to apply. Okay, then what I will get? What I will get is voltage drops is equal to voltage rise. So minus R11 I1 minus R12 I1 minus I2. Okay, then what is the voltage across the independent current source? It is unknown. Okay, so we'll assume something, that is Vx, for example. Okay, then as per this clockwise direction I have to take minus Vx. Okay, then plus V1 is equal to 0. Current through R11 is I1, current through R12 is I1 minus I3, I1 minus I3 with respect to mesh 1. I am taking the drops, that's why minus I am taking, minus R11 I1 minus R12 I1 minus I3. Then the voltage indicated for the independent current source is I0, that is plus minus is there, so ending symbol is minus Vx. In that clockwise direction we are leaving with the plus symbol for the V1, so plus V1 is equal to 0. Okay, now you apply KVL for mesh 2. Okay, apply the same thing as per the procedure we go. So minus R33 into I2 voltage drop across the R33 minus V3, then plus Vx. In the clockwise direction if you go, it will be plus Vx minus, what about R23? R23 I have written with respect to mesh 2, what is the current through this one in the clockwise direction, I2 minus I3 is equal to 0. Okay, I have applied KVLs for mesh 1 and mesh 2. Okay, now I will take mesh 3 also. KVL at mesh 3. Okay, so what I will get? Minus R13 into I3 minus R23 into R23 is between 2 and 3. So in the clockwise direction the current is I3 minus I2 minus R12 into R12 is for 1 and 3 with respect to mesh 3, the current in the clockwise is I3 minus I1 is equal to 0. Okay, up to here it is okay, but how many meshes we have? Number of meshes 3, number of mesh currents 3. So number of mesh currents to be calculated is equal to 3. Okay, number of KVLs can be applied is equal to 3. Number of equations obtained is equal to 3, but number of unknowns is equal to 4. I1, I2, I3 and Ix, sorry, I naught, otherwise Vx, whatever it may be. Okay, I1, I2, I3 and voltage across the I naught they will give, but we don't know what is Vx. Number of unknowns 4. Okay, so not possible to calculate. So what to do? What to do means just add equation 1 and equation 2. That means KVL for the mesh 1 and KVL for the mesh 2. You simply take addition of these two. In equation 1 you are finding minus Vx, and in equation 2 you are finding plus Vx. These two will be cancelled. Okay, then rest of the equation, if you observe, by adding these two you will get the new equation, that is minus R11 into I1 and minus R12 into I1 minus I3. It is plus V1 is equal to 0. Okay, next for the second mesh equation, what are the remaining things we got? Now we are adding now. So for the second mesh equation, minus R33 into I2 minus R23 into I2 minus I3. Okay, and you have here minus V2 is equal to 0. So by adding this mesh 1 and mesh 2 KVL equations, we got this is the equation. Now you got equation in terms of V1 and V2 only. Vx has been eliminated, and we have third equation, that is mesh 3 KVL equation. Okay, so that will be in terms of I1, I2, I3 only. Okay, and here you got I1, I2, I3. So in I1, I2, I3. So finally we have, this is the fourth equation and this is the third equation. Two equations are there for the calculation of the three unknowns. Okay, I1, I2, I3. Now you don't need to bother about what is Vx, because it was gone. Okay, so two equations, three unknowns. Again difficult. We need three equations for the three unknowns. So actually this fourth equation, if you observe, this is the equation obtained by taking the KVL for the combination of the meshes 1 and 2. Okay, here if you consider this particular circuit, if you see, if you write KVL combining the mesh 1 and mesh 2, okay, then you will get that fourth equation. You can check that one. Plus V1 minus I1 into R11 minus R12 into I1 minus I3. Then go to R23 element. You see, I have covered V1, I have covered R12, I have covered R12, R11. Then you go to this R23. Okay, that means we are applying for this one. That is called super mesh. Okay, that is called super mesh. So, what is the next equation I will get? Minus R23 into I2 minus I3 minus R33 into I3, otherwise I2 minus V3. Close the loop. So this is the equation we got as the fourth equation, minus R11 I1. Okay, plus V1 is there, minus V2 is there, otherwise V3 is there, whatever it may be. I'm taking here V3. You also take here V3. Then minus R12 into I1 minus I3 is to minus R33 into I2. Okay, minus R23 into I2 minus I3. Like this we got all the equations. Okay, then here minus R33 into I2 is also there. Okay, here already it was written. 1 2 3 4 5 6 1 2 3 4 5 6. Okay, 6 terms we got. Okay, so in this way we can able to apply mesh. But what about number of equations? So always you apply. We have remember one thing in case of the nodal analysis, that KVL is to be applied at the super node. Its opposite is KCL is to be applied for the super mesh. That's it. Okay. If you think about this one, I0 is the current source. Okay. Here mesh 1 is there. Here mesh 2 is there. So in mesh 1, current is passing like this I1. In mesh 2, current is passing like this, that is I3. Okay, so write I naught in terms of I1 and I2, that's it. I naught is coming down, I1 is also coming down, but I2 is going up. So I naught is equal to I1 minus I2. That's it. So now you got third equation also in terms of I1 and I2. So in case of super mesh circuit, in the circuit is involving the super mesh, equations are to be obtained. One is KVL for the super mesh. In our case, mesh 1 and mesh 2. Then KCL at the super mesh. Two equations are ready. Next KVL for the third loop, third mesh. So three equations, three unknowns, I1, I2, I3 can be calculated. Okay, you can compare this one exactly with the super nodal analysis also. Thank you.